Good morning, everyone. So welcome to my YouTube channel, Math Sutra. So today we are going to see 25th lecture on Riemann integration. So let's start today's session now. So we write a corollary of last lecture, 24th lecture. Okay. So corollary. Let f and g are Riemann integrable. Let f and g are Riemann integrable. Okay. And the derivative of f also Riemann integrable. Okay. Then integration a to b fx gx dx is equal to fx integration a to x gx minus integration a to b. So here is integration limit a to b and the derivative of f. Okay. And integration of g a to x gx. Okay. dx. Let's prove it. How it will be proved. Okay. So, okay. So, since f dash is Riemann integrable, okay, by second fundamental theorem of integral calculus, we have what we have fx minus fa is equal to a to x f dash x dx. So it means what? fx is equal to a to x fa fa plus a to x f dash x dx. Okay. And what is and we write capital GX is equal to also we write GX is equal to a to x gx dx. Okay. Now by integration by parts formula, we have what we have a to b fx gx dx will be equal to fx gx a to b integral minus a to b f dash x. Okay, f dash x and f dash x and gx dx by the integration by parts formula. Okay. Now put the value of gx here. What is this? A to x gx a to b minus a to b f dash x and what is gx? A to x. Okay. Gx dx and dx bracket close. Okay. So here dx is there. Okay. So let it write properly here. Corollary. This dx dx. Now let's say it's 1. Now what is this? We know that integration a to a gx dx is actually 0. Okay. So from 1 and 2 what we have? Okay. But we have to write the formula for this. Okay. So we are done actually. Okay. No need to expand it properly. So I'm writing action, no problem. So it is done. Okay. Actually. Because in corollary, we have to prove up to this. Okay. So corollary is done. Okay. So we have proved the formula. So this is done. Okay. So we have, I'm writing this in next line. A to B fx gx dx is equal to fx integration of g a to x gx okay, gx dx a to b minus integration a to b differentiation of fx differentiation of f integration of g a to x gx dx. Okay, dx. And then this bracket is closed. So we are proved. This is proved. Okay. Now next. Now we are writing a particular case of particular case of integration by parts formula. Okay. Let F and G to R A B such that F dash and G dash also remain integrable. Okay. Then A to B F X G dash X G X is nothing but equal to F X G X A to B limit A to B minus A to B G X F dash X dx. Let's prove it. Okay. Prove. Okay. Put Fx is equal to Fx Gx. Okay. Gx. For all X belongs to closed interval A. Okay. Then F dash X is equal to Fx G dash X plus F dash X. Okay. Gx. Okay. This belongs to R A B. This function belongs to by second fundamental theorem of integral calculus, we have A to B, okay, F dash X dx is equal to F B minus F A. Okay. So what is this? Put the value of this. This is Fx G dash X plus F dash X Gx dx. What is this capital F? F B G B minus F A G A. Okay. Okay. So now open this. What is this? A to B fx g dash x g dash x dx plus A to B f dash x g x dx. And how we can write this? This we can write fx gx A to B. Okay. So what we got actually, you bring this side here. So this implies A to B fx g dash x dx is equal to fx gx limit A to B minus integration A to B f. Okay. We can bring this side here. We can bring this side here and we can write gx first. F x dx. Okay. So formula is proved. Okay. So now it is proved. We need to prove only this much. Okay. So this is proved. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe on my YouTube channel. Thank you very much for today's lecture. Thank you very much.